Hi, I'm Sanka. I hope every one of you have received the MATLAB Simulink template via email. In this video, I will explain how to use the MATLAB Simulink template to simulate a kinematic model of a non-holonomic wheeled mobile robot. If you have already installed the MATLAB standard version, you should have MATLAB Simulink already installed in your computer. In order to initialize the Simulink environment, you could type simulink in the command window, or either you could use the Simulink library icon under the Home tab. Either way, you should be able to open the Simulink library browser. Now, once you have a Simulink library browser, you could either use the open file button, or you could go to file or use open. But either way, you should be able to locate your files and load it into the MATLAB Simulink environment. Okay, now that we have our Simulink template open up, let's take a closer look. As you can see, first of all, we have two boxes or two commands for left wheel voltage and the right wheel voltage, and those signals are feeding into two boxes called left motor and the right motor. And if you go and click on one of these boxes, it will take you to the inside of the box, and there you can see the transfer function implementation of the DC motor model. Now, this transfer function is a standard function that comes in the MATLAB Simulink libraries. All you need to do is enter parameters. Now, long story short, so now this transfer function represents the DC motor model that outputs at speed. Now, the voltage is the input and the output is the speed. Two speeds of the wheels are feeding into another box called nonholonomic differential wheels robot. There we have implemented the kinematic model of the robot. So let's take a look. Now we have two inputs that corresponding to left wheel speed and the right wheel speed. We use these addition boxes to calculate heading speed and the angular speed, which are feeding into another box where we have implemented some set of equation. Actually, those equations can be found in equation number 4 in the lecture notes. And altogether, this will represent the kinematic model. Now, as you can see, there are integrators. That is how we're gonna integrate the velocities and calculate our theta and x and y positions. As you can see, now the outputs are x, y and theta. So these integrators does the job for us to integrate the velocities over the time. And so going back to the main implementation, and the output of the non-holonomic differential wheel robot are x, y and theta, and these two box xy graph and the plot vehicles are our plotting functions. Now xy graph only plots the center position centroid of the mobile robot, and the plot vehicle gives you a simulated mobile robot figure in 2D space. Now once you have everything set up, you can just run the simulation model and see what happens. To set up the solve option, we can click the model configuration parameter icon that looks like a gear wheel, and there you can select the solver tab, and under that you can find the solver option, and the type has to be fixed step, and the fixed step size should be 0.1. And then one more thing, go to the XY graph and double click on it, and the sample time should be set up as 0.1 as well. Now with that, I think we are ready to do the simulation, and I have changed the left wheel voltage to 2 and the right wheel voltage to -2, and now the simulation time is 50 seconds, and then we are ready to run the simulation. You can go ahead and click the play button or the run button, and if everything goes well, you can see the simulation. So now this is the XY plot, and this is the simulation of the robot. Now this makes sense with the kinematic equations, right? Because now we set the left and the right wheel velocities or the voltages to be same in magnitude and opposite of signs, and that should create the forward heading velocity without any rotation. Now if you want to have a rotation around its center axis, we can stop the simulation, and what I'm going to do is I'm going to change the sign of a one wheel to. So now as you can see, both velocities are positive and has the same magnitude. Then now I'm going to run the simulation again. Now as you can see, XY plot only shows a one dot, and the simulation of the robot, you see it's rotating around its own axis. As a final exercise, let's try to move the robot on a circle. To do that, I'm going to change the robot right wheel's voltage to -1 and hit the run button. Now as we can see, the robot is running on a circle. And as an exercise, I want you to think about how to determine the radius of this circle. You may need the heading velocity and the angular velocity of the robot. Now this is how you can simulate a kinematic model of a non-holonomic differential wheel robot in a simulink environment. Now you feel free to change the velocity commands and try to obtain different shapes and different trajectories of the robot, and see how you can play with this simulation. And I hope you find this video helpful and educational, and if you have any questions, please feel free to email me at any time. Thank you and have a nice day.